Hey everyone, in this video we're going to talk about radicals and some of the rules associated with them. So let's just give an example. Radical 16. So this gray part right here is called the radical. Radical. And the blue part right here, the number underneath the radical, is called the radicand. And we know this can be read as radical 16, or it could also be read as the square root of 16. Radical 16, or the square root of 16, is 4. So that's what that evaluates to. But now let's talk about some of the rules. So a lot like the last video with exponents and the rules associated with those, radicals also have their own product and quotient rules. So let me write that down. They have a product rule. And they have a quotient rule. Let's discuss the product rule first. So the square root, or radical, a times b equals radical a times radical b. So this is best explained through example. Let's say we have the square root of 36. So the square root of 36 you might recognize right away is just 6. But let's say we wanted to solve this by applying the product rule. So what are the factors of 36? Let's write down 36 right here. What are some factors we can think of? Well, there's 2 and 18. 2 times 18 is 36. And if you break down 18, that's just 2 times 9. So let's take this 9 and then let's multiply these two 2's together to make 4. And basically we can rewrite 36 as 9 times 4. 36 is just 9 times 4. And there's a special reason why I want it rewritten this way. So 36 is 9 times 4. Therefore, the square root of 36, or radical 36, equals radical 9 times 4. Perfect. And as we could see right here in the product rule, the radical a times b is radical a times radical b. Therefore, the square root of 9 times 4 is the square root of 9 times the square root of 4. And we can evaluate these individually. The square root of 9 is 3, and the square root of 4 is 2. 3 times 2 is 6. And that's another way of arriving at the answer using the product rule for radicals. So now let's go ahead and focus on the quotient rule. And the quotient rule is also very similar. Instead of multiplication, we'll be using division. So let's say we had radical a divided by b. This is the same thing as radical a over radical b. So that is the same, and of course, to give a quick example, let's say we had radical 9 over 4. How do we evaluate this? Well, we can use the quotient rule. Say this is the same as the square root of 9, or radical 9, over radical 4. And what's the square root of 9? That's 3. What's the square root of 4? That's 2. So radical 9 over 4 evaluates to 3/2. And that's the answer. So those are the product and quotient rules. And just a few more things about radicals. Let me go ahead and rewrite the quotient rule. So radical A over B equals radical A over radical B. One more thing about radicals is that a radical written like this, so let's call this radical x, it's always implied, if there's no number here, that the index is 2. So this is the square root of x. If there's no number there, then you always imply it's the square root of x, meaning that this index right here is 2. But the index doesn't always have to be 2. There are third roots, fourth roots, and an infinite number of roots. But what does it mean for a number to take the third root of a number, for example? So let's go ahead and take the third root of 64. So what's the third root of 64? Well, this happens to be 4. And why does this work? Because 4 to the third power is 64. And just to show you, if we took 4 times 4 times 4, then these would evaluate to 16, and then 16 times 4, 16 times 4, that gives you 64. So therefore the third root of 64 is 4, but this number right here, whatever root we're taking, that is the index. And that's just some terminology for radicals. So I hope this video helps you understand radicals more. And if you have any questions, please leave them in the comments down below. And as always, thank you for watching.